Hi everyone, we're starting day 2 review of second semester. So again in chapters 7, 8, 10, and we're pulling in chapter 9 as well. First problem says to solve the system by elimination. So solving systems, again, like I said yesterday, you're trying to find the point that makes both of these equations true at the same time. So you're looking for one point, one ordered pair that's going to make those true. We're going to do this algebraically using elimination. Now elimination, you actually want to leave them lined up, ax plus by equals c, ax plus by equals c. With elimination, your goal is to make opposites. So we either want these numbers to be opposite or these. For me, I think I want to do 8 and 3, making those opposite. I know these are already opposite signs, but it's easier for me to look at 3 and 8 and say that the least common factor that they have, we can make those both 24 and negative 24. So I am going to go ahead and multiply my top equation through by 8. And I'm going to multiply my bottom equation through by negative 3. And so that will get me my opposites. And then once we have our opposites, we can add them together. So I'm seeing 56x plus 24y equals, I'm going to do some math off to the side, 19 times 8. 9 times 8 is 72. So we drop the 2, carry over the 7. 8 times 1 is 8. 8 plus 7 is 15. So I'm saying 152. Go there. Multiplying through by a negative 3. A negative times a negative is a positive. 9 times 3 is positive 27x minus 24y equals 23 times 3. Most of us can probably do that one in our head, but I'll show it off to the side. 3 times 3, 9. 3 times 2, 6. So negative 69. Now, because I have my opposites, I can eliminate. 24 minus 24 is 0. That eliminates. I'm going to add here because they're like, or they're same signs, so, and they're like. So I get 13, carry over the 1, 5, 6, 7, 8. 83x equals, I subtract over here, so I'm going to borrow. I'm subtracting because they have different signs. 12 minus 9 is 3. Borrow. 14 minus 6 is 8. I get a positive 83. So now I divide to get the x alone, and I'm seeing that x equals 1. You can pick either of the equations, sub in to find y. So I'm going to pull that first equation, which says 7x plus 3y equals 19. And I'm going to sub in a 1 for x. So I get 7 plus 3y equals 19. Subtract over the 7. 3y equals, let's see, we're going to get 12. And then we divide by the 3 to get y equals 4. My ordered pair answer is going to be 1, 4. This is the ordered pair that would make both of these equations true at the same time. 8.1 through 8.3 review again. Exponent rules. We have no parentheses, so no multiplying. You know that I always like to work across next to clean up my numerator and clean up my denominator if I can. I like to organize the numbers and then the letters alphabetically. So I see in the top 2 times 4, which is 8. We don't add those. We multiply those. Those are the bases. You add the exponents. I have a y to the first, x to the 0, and x to the 4th. After my number, I'm going to put my x's. So 0 plus 4 is x to the 4th. And then I have a y to the 1st in the top. In the bottom, I have a 3. I have an x to the 3rd. And I have a y to the 1st. None of these have the same base, so I'm just organizing them with the number, then alphabetically with my letters. Here I had one adding to do and one multiplication fact to do. Now I can work top to bottom. These don't have the same base, so my 8 and my 3 are staying. These have the same base, so I'm going to subtract those exponents. These have the same base, so I'm going to subtract those. 4 minus 3 is 1, and 1 minus 1 is 0. Anything to the 0 power, remember, becomes a 1. So I'm saying 8x over 3 is my final answer for number 4. Number 6, we need to factor, so we're going to use the factor box in 6. We should always look for a GCF first. 7 is the smallest number. 7 doesn't go into 16 evenly. 7 doesn't go into 15 evenly, so I'm ready to go with my box. Setting it up, leading term here, minus 15 here, constant there. Two numbers that multiply to give me 7x squared are 7x and x. Now I need to get positive 15. I'm thinking I'm probably going to try the 5 here and the 3 here. And let's just see if this works. And then I would put the negative with the 5. And so the check is on the diagonals. So checking, I get 21x minus 5x. So 20, 19, 18, 17, 16. So yeah, 21 minus 5 is 16x. So this box does work. And then we write our factors like we read. So 2 sets of parentheses going from standard form to factored form. 2 sets of parentheses multiplied together to get you back to that original standard form. I'm seeing 7x minus 5. In my box, I'm seeing x plus 3. Number 8, we need to graph this quadratic function. This quadratic function is in standard form, so I'm going to list A, B, C. I can see that A is 2, B is negative 4, and C is negative 2. I'm going to find the vertex, which we know is the highest or lowest point. I'm going to find the x-chord by using that formula, opposite B over 2A. The opposite of negative 4 is 4 over 2 times 2, because A is 2. So I get 4 over 4, which is 1. And then to find the y-chord, we go back to the original. Back to the original. Everywhere there's an x, we are now going to put a 1. We have to be careful with our order of operations here. So I need to square first to get 1. I'm going to take 2 times 1. I can multiply these to get a negative 4, and then the minus 2 falls behind. Multiply these to get 2. 2 minus 4 minus 2, which 2 minus 4 is my equal sign, is a negative 2, and a negative 2 and a negative 2 is a negative 4. So my vertex is 1, negative 4. I'm going to go ahead and make a table. Put my vertex in the middle, pick numbers that are smaller, and pick numbers that are bigger. Remember, we said the shortcut says if 0 is in your table, you can take the C value and put it across from it. So across from 0, I'm putting negative 2. The symmetry piece allows you to also put a negative 2 across from 2. Now I only have to do one more set of work. One more plugging into the original to find out what is y in my table. I'm going to plug in 3 back into the original, so y equals 2 times 3 squared minus 4 times 3 minus the 2. So 3 squared is 9, so I'm going to have 2 times 9. Multiplying these, I get a negative 12, and then that minus 2. 2 times 9 is 18. So I'm going to have 18 minus 12 minus 2. 18 minus 12 is 6. 6 minus 2 is 4. So when I plug in a 3, I get out a 4. Symmetry allows me to also put a 4 across from the negative 1. Graphing, I'm going to move 1 to the left and up 4 tick marks. Put a point. 0, don't move left or right, just go down 2. Put a point. 1 to the right, down 4, put a point. 2 to the right down 2, put a point, and 3 to the right up 4, put a point. This is just a function, and there's an equal sign there, so I'm just going to go ahead and connect. No need to worry about any shading here. It's not an inequality. There's my parabola, and I have finished graphing that quadratic function. Have a great day, everyone.